All right, well, welcome everyone to today's office hours where we are going to talk to you today about some tricky logs that we've come across. In particular, I'm going to talk to you about container or microservices logs and how do you deal with multi-line logs in particular. And my peer, Pablo, is going to talk to you about Azure Flow Logs later on. My name is Ahmed Kira. Sorry to introduce myself first, but I am a solutions engineer with Cribble. And let's go ahead and get started. So there's two parts to this. And my part here, I'm hoping to cover in the first 30 minutes. And because this is a problem that's worth explaining, at least kind of the background of, I'm going to just do a little primer on containerized application logs and the challenges that what we face with those, and then go into actual pipelines. In particular, there are two pipelines that I'm going to walk through and actually show you what the data looks like in the destination. In this case, the destination is going to be Splunk. When you do the process the data with one pipeline or with both pipelines. So we'll get into that. And then Pablo, like we said, is going to get into Azure Flow Logs. So a primer about containers and microservices logs. There's really, I mean, Docker is most popular one out there. There's Creo that Kubernetes is starting to adopt, Containerd as well, that's out there. But Docker is still pretty popular. And the default logging method for any application logs that originate from Docker is to send them to standard out, and then Docker is going to create a JSON format of that event where it's going to take the original log. So in this case here, the actual log line is the original log, and it's going to add some other fields here. And that list of fields will vary from one instance to another, but everything's going to be wrapped in this JSON. And then you go to Creo or Containerd, they're adopting this different standard where rather than having JSON as the default, and by the way, Docker does support other methods here besides JSON like journal and syslog. But for Creo, what you'll find in most cases a format similar to this, where you have a timestamp at the beginning, standard out or standard error, the method that the data was published. And then you're going to find increasingly a letter like this, which reflects whether that's going to be a full line or whether that's going to be a partial line. So this is where multi-line logs will come into play. And then the actual log entry after this. So bottom line is the actual raw log that people care about is just a small portion of this payload. And what does that look like then for multi-lines? Well, this is what it'll look like in the case of Docker. So you'll have one event here that will basically be for the first line, a different event that will be for the second line, and so on. So we need some kind of time breaker or timestamp breaker most likely here to distinguish the beginning of every event rather than just going off of what Docker is telling us and that each one of these is a different line, because they're really not. And then in the case of Creo or Containerd, looking at their format, similarly, usually in the beginning of every actual event, there's going to be a second timestamp, not to be confused with this timestamp at the beginning, which is more so the microservices time, as I'll call it, which is the time that the containerized engine processed that log. But this is the second timestamp here is the actual log timestamp. And this is where we can have line breakers at this point. So if we look at the second one here, the events right after this, they're all PPP here. And the final one has an F. And so this is the last line in this particular log, right? So this is either through the Fs or either through the timestamp here. The second timestamp is how we can distinguish beginning and end of the events. And so what's out there today to deal with these kinds of logs and containers? So you could use, and a lot of people do use, agents like FluentD, FluentBit, Vector, even a Splunk Universal Forwarder, deploy them as daemon sets or deploy them as sidecars to look at specific containers. Capture those logs, do some pre-processing of them, and then send them on to the destination. And while that will work for small instances or small nodes where you don't have too many containers running or you don't have too many events per second, you'll quickly get into scaling issues with all of them. Fluentd in particular only can handle about 5,000 events per second. And while that might seem like a large number, in production in the real world, I know many customers that have superseded that number very quickly. And so you might look at other solutions like FluentBit or other ones out there, Vector is another one, and those might scale a little bit more, but you're still going to come across that events per second ceiling of what one of them can handle. And the other problem with this approach is when you're deploying a daemon set or you're deploying a sidecar, you are contending for resources on that node with your production applications that are also running. So you're contending for CPU just to have Fluentd run and process the logs as your production web server that is also running in another container on that same node. In fact, I actually worked with one customer a couple of years ago where just by deploying Fluentd, they immediately noticed performance degradations of their website because they're for their front-end application. And so what other alternatives are there to this? This is where you can potentially have the containerized engine load the drivers, load these logging drivers as they're called in there, and then just forward the raw standard out data directly to Cribble logstream. And you can, will basically listen on either an HTTP input, or there's a couple of Splunk ones there we support, a FileBeats input. We'll listen via various means there to collect that data, and then you can offload all of the processing of reassembling all of these logs and making them look the way they should, away from the node, away from your production applications instead of running alongside of them. But if that's okay, if you're okay running Fluentd or FluentBit, that's fine too. You can also still forward those logs onto logstream, and we will still be able to pre-process them some more and provide some additional value from that pre-processing. And that's actually what I'm going to be showing you here today. And so you're probably now wondering, a few minutes here of slides, I want to see this in action. Enough of the slides. So here's what I'm going to show you in this last one. And let's actually put this in presenter mode just to have it take up the whole screen. Does this show in animated format right now with just one screenshot in the top left?
It does.
Cool. So what you're first going to see, the raw unprocessed log is going to basically look like this with different log lines, all JSON. We're going to take this. We're going to first do what's called a pre-processing pipeline. That's going to convert it and make it look similar to this. So now it'll look more like the original log file itself, or the log event itself. And so here's an example of an actual multi-line event. And then from there, it's one thing to just write it to your destination as such, but why do that when you can make it more consumable in the destination? So there's going to be another pipeline that's going to basically enable better searchability in Splunk in this case, where we're going to create some key value pairs, as well as an array of the Java stack traces here, so that they become more easily searchable and you can get to root cause faster without having to do any regular expressions on the Splunk side. So let's get into that. Here I have my log stream instance. The first thing that we need to work on isn't a pipeline, but it's an event breaker rule. So we just access knowledge once we're in the leader node configuration, go to event breaker rules. And I already have a couple of them here created under this rule set for timestamp at the beginning. And the one I'm going to go through is the second one, this JSON file. Notice I have another one here that's for the CREO or containerd format as well. So if I open this one for the JSON format, and let's upload a sample file so we know what we're working with here. So I'm going to select this one here. Here now is what the events, the raw events look like before any processing in Logstream. And I think I might have selected the wrong one. Yeah, I'm in the nano, not in the JSON one. So let's select the right one this time. There we go, JSON file format. Upload, Docker, OpenShift. Here we go. So here's my event breaker rule. I'm basically telling it the log field, which is going to be at the beginning of the event, needs to always start with a date, right? So this is a match. This is not a match. And then furthermore, I am in this case here selecting auto timestamp depth. I could do manual for this specific format that I have here, but I'm keeping it as auto timestamp depth and just to accommodate other formats that might exist. And if there is another format, we might need to also update this event breaker rule to account for that format. And then the last thing that I'm also doing here in this rule, this event breaker rule, is I can add fields to these events so that before they go through any pipeline, they're better shaped and ready to be processed. So here I'm creating a field called multiline, and I'm basically telling it, look for more than one instance of a new line character, because each of these events, even the single line events, actually have a line a line break at the end. So we're telling it, look for 2 of them here at least. Look, and that's inside raw. And then if there's a match, assign that field, the multi-line field, to true, a Boolean field. And if it doesn't match, assign it to false. So we're creating this field in advance. And then by click on out, we can test and see, are we parsing things right? And so now looking at this first raw one, let's expand this. Here we go. So this looks right to me because this is the first line of the event. Here's the first line of the next event. So it broke the events correctly. And then also here's this multi-line field that's going to get populated as true, true. Here's a false one. So this is an actual single line event here in this case. And this is where I can use this field to basically help me create my pipelines later on to treat multi-line different from single line events, for example. So at this point, I have my line breaker rule created. I can go ahead now and work on my pipelines. So let's get out of here. We're going to now go into pipelines. And when I first started this, I had here this, let's see, it's actually this one, this microservices JSON preconditioning that has 12 functions in it. And I thought through this methodically, if you will, where I was first looking for single line events, doing some stuff on them, and then looking at multi-line events and doing something else on them. But in talking some more and swapping notes with some of my peers, we found some better and more efficient ways of doing it. So the first method I'll show you here is only 2 steps. We do this regular expression extract. And let's load that sample data set that we had in the event breaker rule. We have it over here as well. And let's disable some of this last eval here, just to see the before and after. So with this first function, this regex extract, we are telling it basically extract the raw event, but create another field, which is the same name as the raw event, call it _raw. And we're also doing global and multi-line, right? This is the important part here, so that it forces it to basically go through every line and do the same regular expression, and then add it all as part of one field. So here we can see in the out, there's an array, and I know this is an array because of this symbol over here, of 5 different lines. And looking at this, this looks weird. Why do I have my original one in here? And then I have how they got parsed, how these 4 lines that are part of the event got parsed and added in here. Well, I don't want this first one. first, when I saw this is what led me down the path of that 12 function pipeline. But there's a way to deal with this. And that way is actually in this eval. And so this is where we can tell it using our JavaScript knowledge. So this is a JavaScript expression input here to do a slice function on the raw field and join them with a new line. So every line, basically, instead of keeping it an array like it is here, and notice these are basically created as one event with a new line in each one of the entries instead of different strings here or different parts of the array, if you will. And then I don't need this one here, this multi-line. This one, because we already did this, so I can get rid of this. And the way this raw slice works, if I add another field here, and let's move this one up just for demonstration. We'll call this new field. And let's copy this here. And if we put like, let's say 2:5 as the, what we want to basically select, or comma, I think it's comma. There we go. And I know I had a mistake there because I had this icon here tell me there's a syntax error. So comma, let's just see what this new field looks like. And let's also look at what the raw field looks like. So save. And I should immediately then over here see the results of my work, but nothing updated. Why? Because I still have this off. So let's turn it on. Save. And here we go. Notice, because we're telling it slice one, what that means basically, we're telling it capture all of the everything in the array from the second field and on. Slice 0 would be the first field. Slide 1 would be the second field. And because we don't have like a comma, another number, it's going to go to the very end. But in the second case here, or first case, the new field, we're telling it 2 to 5. Well, that's exactly what we have here. We have lines 2, 3, and 4, basically, everything up to the fifth one there. So that's how we can also extend this slice command or function. But this is really what allowed us to, instead of having 12 steps or 8 steps, because we had other comments in there as well, make it down to 2. So now that we have these 2, let's save. This is now the format of how these events are going to look. And if we look at a real Java exception message here, here's a real one, right? We've redacted some information in it. Here is also, this one's a single line. Notice multi-line is false. But if we open that one's again one of the same ones. This one's a different one. This one's this featureizer error. And same thing. It makes it look just the same as if it came from a Linux host that is reading the log files directly, right? So at least we've pre-formatted it, we've preconditioned it, if you will, now, so that we can apply one pipeline against this data set, as well as any other data set that's coming in the same format, right? So rather than having to have a different pipeline that's doing the same thing for this format, I'll just have one. And how does this look like if I were to just send this directly to Splunk today with this format? So I have a Splunk instance here. If I go here to my routes, I have 2 routes. I have one here. The first one is this end-to-end one, but the second one is pre-processed directly to Splunk. And this pre-processed directly to Splunk, we're basically not doing a second pipeline against the events. And here's what the first one looks like. So with no second processing, just the pre-processing, this should look familiar. This is how they would have gone into Splunk if a universal forwarder were sitting on a Linux host and reading those files. But again, you're not taking full advantage of Logstream if you just stop here. So let's go back to Logstream. Let's go look at that pipeline. So we just looked at the preconditioning one. There's another one as well, another pipeline here, this alternate. Just know here there's, let's go back, wrong one, alternate. Instead of 2 steps, you can use 1 step by using the function, by using the mask function over here. So there's many ways to do this. Using this mask and using the regex extract and eval method in the last scenario are probably going to be the best ones, because you're going to reduce the load on your log stream server by using one of these 2 methods. But let's go now to the second one. So the second one here is this log4j pipeline. So idea here is, regardless of what the format is, let's have one pipeline to process it, where they came from containers or they came from Linux hosts. And the main things to call out here, there's other things that are being done in this pipeline to look at other events besides these multi-line Java events. But if I focus on just the multi-line Java ones, I have a regex extract. Let's load those events again here, these preconditioned ones now. So this is after the first pipeline has processed them, right? At the beginning of each one of these events, there's a timestamp, and then there's also a thread. Why have these populated in every event when you can just have them as extra fields that go into Splunk or into Elastic? So if we go here to the out, we notice here now we've reshaped the event to, and in this case, what do we have? This one is a different format, but we just look at the exception ones. These are the only ones we care about here right now. We removed this timestamp. We also removed the log level, and we removed the thread, right? Those are all right here. Error, thread right here. And the timestamp is already preserved in another, it's already, the underscore time is already a timestamp. So we made the event smaller, and by doing this on its own reduced well, let's actually look at this one alone. This one reduced in size 25%. I didn't show it in the prior pipeline, but over there it actually reduced by 60%. So you reduce the event that came from the microservices engine by 60%. And then here you're further reducing it by 25%. But you're also adding these extra fields in order to make Splunk more easily searchable, or more faster really to search by referencing index time fields instead of looking at the search time content. And then the other thing that I'll call out here is, in this event reshaping, what we're actually doing, let's make this wider so it's, and maybe just make it easier to read slightly. We are creating field value pairs. So if we go event 3 here, let's go at the in. Event 3, here's what it looks like originally. There's, this stuff on line 1. There's this stuff on line 2 over here, right? And then followed by this colon. What we're doing is basically extracting that, putting it into this exception line 1 root field, creating another field, exception line 2. There's another one, detail here, line 2 detail. And then the rest of the lines that are part of this at, all these Java components, we are populating them as an array for this field, exception stack. And why do it? This is where you're setting it up to be primed for the destination. And so when this goes to Splunk, here's what it'll look like now. So let's go look at the raw events. Here's what it'll look like. You have the exception line 1 root. You can quickly see all of your various values here, create trend charts on this. And the exception stack, because all the lines are different values in an array basically, and they came into Splunk as part of a JSON, you can now report on these without having to do any other crazy regular expression, right? You can see which ones have the highest occurrences, which ones have the rare occurrences. And you can take it a step further by doing a search similar to what we have here, where you can look at what is the first component, their Java component in the stack. What is the last one in the stack using these Splunk SPL components here, putting them in a table. And here we go. So you can basically now, here, this is just for demonstration purposes to show that you can put these in a table, but here is the first and the last. So these are things you can include in an alert in Splunk, right? So now the developer, the DevOps engineer that gets the alert can have this information embedded in it. And this was all made possible by Cribble Logstream, by basically doing this pre-processing, taking what was a pain in the ass before, and now making it a lot simpler. So that's my part. Let me open it up to questions here before I give it to Pablo. Is everybody still there?
We are. Well done, Ahmed. Well done.
No questions from the broader audience?
Well, what are we seeing in general about what are people using for containers to pull it off? I mean, I've talked to many huge, from Tesla to many other places, and their sidecars are getting overloaded. They're having all these problems and stresses. Like, what's the latest? And this stuff changes every 30 days, by the way. What's the latest? We want to share?
Yeah, what are you folks using out there in the real world to try to do this pre-processing? Is Fluent working out for you? Fluent Bit, something else? And how is it working out?
I've heard some Fluent Bit. I've heard that being used in places, but it gets maxed out. And
I can say that right now we're suffering with it until we get Logstream fully in place and we can deal with it.
Yeah, I keep going back to this, but to me, one of the benefits of using Logstream in this case is you're leaving your Kubernetes node to not have to contend for resources with Fluent or Fluent Bit. You're leaving all that processing to be done offsite by Logstream rather than as sidecar or a daemon set there locally on the node.
I mean, we're looking at for a worst source type in one environment or in a few environments in one business unit, we're looking at about 1 terabyte of savings a day, I think.
Wow.
Just from unwrapping this log from the JSON.
Nice.
So we can't wait to get there.
Now, in some cases, customers, some people still want to use Fluent and Fluent Bit. They might still work for you, but all they're going to do is basically making those multi-line events into a single event, right? That's all they're going to do. You're still going to want to do this extra processing like I've done here, and not just to reduce what you have going to your destination, but also to make the searching in it easier, right? Making, as I like to say on my LinkedIn profile, make the data consumable again. All right, well, I'll be here through the end of the hour. If there's any other questions, please feel free to bring them up. Otherwise, let me give the floor to Pablo.
All right. Thanks, Ahmed. Let me share my screen now. This is this one. Okay. All right, cool. Can you see my presentation?
Yes.
I'm going to go with yes.
Yeah, I can see it.
Okay, awesome. All right, so we're going to switch gears quite a bit here. I'm going to talk about some logs that come from Azure, specifically the network security group flow logs that happen to be just one massive JSON object. So let's get into that. And we're going to get into how we can process these with Logstream to get the stuff that we want out and then process it in a way that we have the data available that we want. So really what these are is these logs get dropped into Azure storage every minute. and they basically log every flow that's coming in and out, or even trying to come in and out of your Azure VPC. And it logs all the IPs, where they're coming from, what port they're coming from, what port they're going to, whether they got blocked, what protocol, like all this stuff gets logged for every single connection that comes in. And it also keeps track of like which security rules were triggered by each one of these flows, and what was the reaction of the security group, policy, whether it blocked it, allowed it, or whatever it was. And like I said, all this stuff gets put into one massive JSON object that gets put into a file that every minute gets dropped into like the Azure storage. So you can imagine that it will turn out to be quite a big thing. And this object itself is basically arrays inside arrays inside arrays, and they could all be of arbitrary length. So the question is, like, how do we go in and process these things, and how do we go in and kind of crack them open, get the stuff that we want, and manipulate it so that it's in the right format, so that we send it out to whatever we want to send it to. Okay, and really what we want is this stuff that's in this flow tuples array that contains all the data that I was talking about. And in the case of what I did here, this is actually taking all this stuff out and calculating some metrics about how much is flowing between different internal and external IPs and ports, how many packets are going back and forth, and how many bytes are going back and forth, and putting those into metrics so that then we can send them off to whatever destination, whether it's Splunk or Grafana or whatever else it is that we're using to track these flows or to see how much flow is coming in and out. That's really the end result of what we're doing here. All right, so basically what I just said here, we go from this thing on the left, which is really the meat of this log that's buried in a bunch of different nested arrays, to something like this on the right, where we now have basically grouped by IPs and ports and protocol is the like the metrics of how much is going between, how much flows and how many bytes and packets are going back and forth between these IPs and ports. Okay, so I'm going to go through how we can do this in Logstream. It's a relatively straightforward pipeline that I've created here. So I'm going to start first with with my event breaker. So my event breaker is pretty straightforward. It's something that you would expect, just like from any other JSON object coming into Logstream. First, I have a filter that's actually looking for that specific string flow tuples, which we see in here, which is the name of this array that contains all our data. And it's basically telling it, hey, split this up. This is a JSON array. At the highest level, the root object in this log is an array. It's called records. So take that out, and those are the events that you're going to send into Logstream. So basically, the data coming into Logstream is like this huge thing, this huge JSON object that contains all these things. And how I'm going to break that down, it's part of a pack that I created that will very easily be installed in any instance of Logstream, where you can just take this pack, install it in your instance. If you're using these logs and you want to either use it as a starting point, or you want to use it for what I originally developed it for, to create metrics out of these logs, you can literally just drop it in your instance of Logstream. Just click on it, hook it into your pipelines, hook it into your routes, and you'll be able to use it basically out of the box. So let's take a look at how I did this. Really, the really interesting part is the pipeline part. I have, of course, some sample data here that I'm going to preview. And you can see in here, like all the stuff that's coming in. all these nested arrays inside of this JSON object. This is the data that I'm interested in. So naturally, when I started looking at this data, I started thinking about what JSON functions in Logstream I can start using for this. I quickly kind of changed my mind about this because I really didn't want to be dealing with how to traverse all these arrays and how many objects are going to be inside of each of these arrays. It's kind of an arbitrary number. So I thought it would be easier for me to just start breaking it as in a text-based and start kind of splitting these things out based on text and patterns inside of it. Okay, so if we go through this, I have everything disabled so we can see exactly what happens as I go through this. But we start with all the stuff again, same thing, all the stuff in here. And I start by basically dropping everything that has the wrong version. So these Azure logs have a version. Version 2 is the one that I'm interested in because it does contain the actual data of how many packets and how many bytes are going back and forth between these connections. And you can see that here is the last four fields of this tuples entry. In this tuples entry as well, you can see a timestamp. You can see a couple IP addresses, which are the internal and external IPs. You can see the ports that are internal, external, the protocol, the life cycle of it, whether it's ending, beginning, etc. The A here means that the security policy accepted this traffic and let it through. And I don't remember what this O is. It's something else, but I'm not going to worry about it right now. So what I do first is I start by dropping everything that is not version 2. Okay. So that's pretty easy. The next thing that I do is unroll this event. So this event can be arbitrarily large for a VPC that's handling a large amount of flows. You can have a lot of events. You can have a lot of tuples in here. So I tell it to split on a text pattern basis and unroll it. And what the unroll function does is it takes one event and based on the split that I'm doing or the function that I'm doing against it, it unrolls it into multiple events. So I'm basically saying, hey, take anything that's when you see a quotation mark, comma, and another quotation mark, which is basically how JSON is structured, how the fields in JSON are sent through. Split those things into different events. So if I enable this and I click on save, you'll see what happens. We'll now have a whole bunch of different events. Instead of having that whole JSON thing in one event in the raw field, I have it all split up. So I have this, then I have the next field that was coming in, I have the next field, and on and on and on. I have a bunch of, events. From one event, I've created like a dozen or 2 dozen or something like that. And you actually see in here that the data that I'm interested in, these tuples, have been split up into their own events. And this is important if you're doing aggregations, because aggregations in Logstream are based on events. When you create an aggregation function, you aggregate one event over the other and over the other. So that was also one of the main motivators for me in splitting these things up into different events so that then I can then aggregate them later into metrics. All right, so once I unroll them, I'm actually going to drop a whole bunch of these. Basically anything that doesn't match that doesn't match this format of a tuple that's defined by Microsoft in this log, because I'm not interested in any other data other than this. So I enable this guy. I drop everything that doesn't have, that doesn't match this regex, which is basically this format. And once I do that, I am now ready to basically take the data that I want, because all the events that don't have the data are dropped. I now have just the ones that I'm interested in. I'm able to go in and extract all these guys into their own fields, like source IP, timestamp, port, all that stuff. So when I turn this on and run it, you'll now see all these things that are that have now been extracted out of the remaining data in the pipeline, which just contains the tuples. And I'm able to basically, split this raw line in the tuple and break it up into a bunch of different fields that I'm going to use later to aggregate. All right, close that guy. So next thing to do is this timestamp. So I didn't mention this earlier, but there is a way that these things are done. Actually, let me go back to this.
Hey, Kasha is tonight. Should
So
I
there
let
is-
Matthew in this real quick?
There is a timestamp in the log up here. This timestamp is not good though. This is a timestamp of when the log was taken, basically the end of that minute. Azure takes logs every minute, puts them in a file and drops them in your storage. This is like the end of that minute period. The real timestamp for each one of these guys is here. It's this little guy. It's the first field in the
That's
tuple.
7.
So what I'm doing here is basically replacing the timestamp that we've taken out, that logstream is automatically taken out when we do the event breaker. And I'm replacing it with a timestamp from the tuple. So you see in here, like the timestamp that we took out is basically the same because it uses the log files timestamp. Once I turn this on and I save it, the timestamp will be updated. Each event will have its own tuples timestamp. So it's just a little bit of cleanup right there in how we deal with this. All right. Last thing, a couple last things that we do. Really, the more important one here is aggregations. And this is where we convert all these events and all this data into metrics that we can then feed into some metric store or whatever. And the way that this is set up is basically, hey, if there is data to aggregate, so if we have packets, if we have a packet listed as more than 0 or some flows that are more than 0 bytes or more than 0 packets, let's process that. Let's aggregate it by summing these up and call them, sum up the packets to source to destination and call it this, packets sent to destination. Same thing from destination to source, et cetera, bytes to source, et cetera. So these are all the aggregations that we set up. And also just as importantly is the grouping that we've done. So I wanna retain the data of, hey, here's the source IP import, here's the destination IP import, here's the protocol. And I wanna be able to basically calculate metrics for every one of those combinations that are in the log. So that's why we do the grouping. And what we end up with, once I turn this on and save it, not save it. And then actually just enable this last one to drop things that are. All right, so what we end up with is these events that are metrics that can, again, be sent out to wherever we want. And now they're grouped by destination IP, port, and all those things that I've specified. And I also have the metrics of how many packets were sent, how many bytes were sent back and forth. So now I can take this, I can send it to Splunk, I can send it to Grafana, New Relic, whatever it is that you're using. And you have all this stuff with minimal latency in your own system of record. You can, just like in any other use case with Logstream, you can send it to a cheaper storage option like S3. You can bifurcate it. You can also set this up so that if you want to do some other type of processing that has nothing to do with metrics for your Azure logs, you can split this. You can split that flow. You can process the whole set of logs this way. You can process the whole set of logs some other way. That's kind of really the flexibility that this gives you. Okay. Last step that I didn't mention here is this drop. So basically, this is some more cleanup where I drop all the other events that aren't metrics that contain the original data that I was aggregating. Not really interested in keeping that. So I click that on, save it, and now I just have metrics. And this is basically what my stream has now been changed into, and I can send it to wherever I want. All right, I'm gonna stop there. Is there any questions, comments on this or Ahmed's part? All right.
Oh, thank you.
All right. I think we're good then. Well, so that's it for today, unless Ahmed, you have something else, but no, Ahmed and I will stick around until the top of the hour. But that's it as far as content goes. Thank you very much, everybody.
One quick question. In general, when you're looking from these microservices, containers, and all these different areas, you're generally seeing a lot of verbosity, a lot of data that you can be extracted. Or is it just the formats that are main?
I'm sorry, I couldn't really hear you very well.
I muted Jenna.
Okay, yeah, can you repeat that?
No, just overall reduction from these different kinds of files that you're working with, and from containers for Ahmed as well. I mean, are they usually pretty verbose? I mean, is it easy to pull off of, or just the pain of getting the data that's just not formatted well? Is that the main use case that you find in the work that you've been doing as a whole?
Yeah, so specifically with this Azure, for example, Azure Log, I mean, these things can get huge. If you have a lot of VMs, if you have a lot of traffic, if you have a lot of policies, these things can get huge. And depending on your use case, being able to take these huge things that are emitted every minute and extract what you need out of it, will just reduce your amount of data considerably. So in this case, like if we're talking about getting metrics out of it, it'll boil it down considerably. If you're looking to get some security data out of it, like are we getting scans? Are we having a bunch or one particular system getting scanned or hit by one particular IP out there? That kind of data is very easy to shape in Logstream, and that also gives you a huge amount of reduction as opposed to keeping all of your logs all the time. So it depends on the use case, but I would say that getting a significant amount of reduction is pretty standard.
What about, I don't know if I can phrase this well enough, but say if you're using Splunk's cloud and you're getting data off of containers from stuff in the cloud, say everything's at AWS, is there anything that Splunk Cloud does that makes it harder then to extract the data? Or I'm trying to think, as Splunk reads the data, is it reformatted in any way that by using Logstream in between creates some kind of advantage, or keeps fidelity because you can send, I guess, a copy to S3? But I'm just trying to think that data coming from containers, does it get changed, or does it come to a new format in Splunk Cloud that then becomes
Yeah, let me take that.
problematic or just messy?
Let me take that, Graham. The raw events coming from containers from standard out, by putting them through Logstream first, you will reduce their size by between 50 and 60% easily. But that's the raw data. Typically, the customers will have Fluent D or something like that in the middle. And if it works for the customer, they can still put Logstream in the middle and reduce the size there by anywhere from 15 to 40%, depending on the application. maybe even more in the case of, say, web access logs or things like that. So it is use case specific, and we'll also, the other important thing, this logstream is not just about reduction. With logstream, what we'll also do is format the data so that it's primed for the destination. So whether that's Splunk or whether that's Elastic, we'll make the data so that it's more easily searchable, or that the searches can complete faster in the case of Splunk by adding index time fields. So we make the data faster to search and more, not just, reduce the size of the data. So there's multiple benefits there to the customers at the end of the day. And there's a question. There's a question on here. Do we have a use case for MS Event Hub to Cribble? And the answer is yes. We have one of our sources. Are you still sharing, Pablo? Let me either share, or we can go to the sources screen there and show. There you go. So we can, in this case here, we will basically directly talk to the API of Azure Event Hub and parse the data that has come into Logstream, convert it to log metrics, do all kinds of cool things with it, so that again, it's more consumable when it goes to the destination.
Yeah, sorry. One last question. I don't know, so I'm going to ask. With the recent Splunk Cloud offerings, and it's not multi-tenancy, are they running stuff in containers? Have they got to that level of evolution that Splunk Cloud customers are running in containers?
No, that is still all EC. That's still all AWS EC2 instances, or in GCP, compute instances there.
Okay, and so is there anything that, because it's got the wrapper of Splunk Cloud around it, is there anything like telemetry wise or data coming off of those containers that is blocked or messed with, so that you can't get the raw logs from those containers because of the fact it's it's a shared service, or a software as a service? I'm just trying to anticipate what customers might say.
Yeah, the format of the data isn't any different. The Splunk Cloud or Splunk on-prem does not reduce or remove, valuable information from the events. It's all administered by the user. But if somebody does want to alter the contents of the events going to Splunk, whether it's Splunk Cloud or Splunk on-prem, it can be extremely difficult, especially like in the case of, say, the Azure flow log there that Pablo was showing, or the container logs that I was showing. You really need something else to do it before it goes to Splunk Cloud. And that's where Logstream can do it at scale without any events per second limitation that you'll hit with FluentD, FluentBit, or any other agent that's running on the containers where the logs originated. Okay, that's the key here. So this is about the containers where the logs originated, not Splunk Cloud itself, or Splunk on-prem, or Elastic Cloud, or Elastic on-prem. Yeah.
So thank you. So that last bit, if you're not using FluentBit, FluentD, you're using Logstream, which is more powerful, so on and so forth. The mechanism from off the container to Logstream is universal forwarder or which?
Yeah, they'll use logging drivers from the container engine. So there's a logging driver that will send to HTTP endpoints. There's also a logging driver for Splunk, and as well as Elastic, that will send to a Splunk HEC endpoint or an Elastic API endpoint. They can use any of those, but rather than that destination actually being Splunk or Elastic, it'll be Logstream, right? Logstream knows all the formats, and it'll process them.
So the tools that are native to the container itself, be it Kubernetes or whatever it may be, will then put it to the right endpoints. Hacker. All right, awesome. Thank you. Appreciate it. Sorry for all the questions.
No, not at all.
Hello, I have one question.
Sure, Snehal. Hi.
Hi. Actually, Cribble is installed in our AWS EC2, and our client has a S3 bucket, and he has a set up one SQS for us and assume role. Also set up the assume role for us. Okay. So can we bring that logs into Splunk by using the Cribble?
Absolutely. You will, within Cribble, since Pablo, you're still sharing your screen. If you go back to sources, you will basically be setting up an S3 input. So this Amazon S3 that he's got on the top right-hand side, that is basically really an SQS based S3 input. So it is really talking to an SQS queue there to see what new files have been added to the bucket, and then going to fetch those files from the bucket.
Right, but which authentication we can use it in this case?
So
Auto or manual?
So there's assume role that's here, and there's auto, secret. Yeah, these three methods right there, as well as assume role. And
Okay.
auto would be as if you have log stream in an EC2 instance within the same account, right? And then you assign an EC2 service role to that EC2 instance. And then it should then have the permissions to read the SQS queues in the S3 bucket in question.
He has a setup assume role for AWS TA. Can we use the same secret key and access ID for this one?
Can you click on assume role, Pablo? So yeah, here is just, there's no key that you put in here. And so yeah, it would be the key for the root account, right? Not for the role that you're assuming, right? You'd be using the key for the root account, and then, or not the actual root account, but the account that you have the key created for. And that account would assume the role. There's no key required, but it does require the permission on the AWS side, right? In order to be able to assume a role or assume that role, so that it can then read the S3 bucket. And
Okay. So we can go with the auto authentication, right? For this one.
Is Logstream deployed in a EC2 instance that has access to that SQS queue, that has IAM rule policies assigned to it to access that SQS queue, or to assume that role, to assume the role that has access to that queue in the, what's it called? The S3 bucket? Is that where Logstream is running?
Okay.
Sorry.
I'm asking you. Sorry, go ahead.
It's not actually. I think we got the answer to what she was looking for. So we're going to use the assume role, but with that method, we have to make sure we're using an SQS queue to get the notifications, right? And I think in our case, we know that the SQS queue actually isn't working right now.
Okay.
So I think we have what we need.
And the SQS is different from the whole assume role versus using secret key thing, right? Let's just make sure also that to distinguish that. So you're, whether you're assuming a role or whether you're just using the secret key, either one of those two has to have access to the SQS and the S3 method.
So we can't just monitor the S3 bucket without using the SQS queue.
To do that, you would want to, Pablo, if you get out of here and go to collectors. And yep, so here, this S3, this basically just talks to the S3, but the trick here is you want to include in the path field, the directory structure, basically, including the timestamps. And perhaps go ahead and post on the community there, or check with your sales engineer for some examples of paths. Because you want to, when you filter by time, then if you want to schedule this and say run it every 5 minutes, you want to make sure that the timestamp or the time directories, the path directories there for the time are accurate, right? You don't want to pull everything from the S3. You want to be able to pass it a filter that just looks at certain directories or certain, what do you call it? Filters.
Yeah, I gotcha. Okay. So we should ask somebody else for an example about what that path structure looks like.
Yeah, and we have some in our demos here. Let me just get one and I can paste it for you here as well. Let's see. So I'm going to post this in the chat. Here's an example where the root directory is Cribble, and then underneath that directory you have a time field. That's what you're basically going to extract the year from the time field. The next one is the month, and so on and so forth there. And then at the end, this one actually has two other fields that we can then reference to filter on source type and host.
Okay, so if we wanted to have, we have like a more, probably slightly more complex bucket structure.
Yeah.
Okay, but this gives us at least direction and we can play with.
Pablo has another example here up on the screen as well.
And it sounds like, so we have like different sources, different source types going into those S3 buckets, or I guess maybe they would all be AWS S3 source type, but we definitely have, like, we want to send them to different indexes and stuff. So if we do this way, are we going to have to set up different collectors for each one of those and be specific with that path, or?
You don't have to, but within a pipeline that you would process afterwards, or even maybe, can we do it here? There's a field section, this metadata section in here. You can create basically new fields where you tell it, hey, if this directory name matches X, then assign it this source type and assign the index to also be, different from another directory structure. And we've got a nice worksheet here. Let me send you the link for that as well. Let's see. That has some examples. I think these examples is really what this is about for me. Let me find it. Here we go. I thought I had it. Sorry, bear with me for just a second. View, show everything. Yeah, so there's this reference card. Here is the link to that. That has some good examples in there of how you can filter to say match up one of the fields that you have in this path that you're referencing in this path. If they match one thing, then assign, source type of X. Otherwise, assign a source type of Y.
Okay, I'm gonna stop hijacking this call, but is this the way that you would recommend to go about it? Like, is the solution scalable with the least amount of management overhead, do you think?
I think SQS is a better path, honestly. This is really geared more for occasional use, if you will, where you could schedule it, absolutely. But I think SQS, you'll have better resiliency because only as files, and also more real time, as the files get added, we'll instantly pick up those files and read the events in there. And then we can just like in the fields section in here, we can assign the new fields, or assign the index and assign the source type field based off of, some parameter that we picked up, or maybe even something inside the event.
Okay, so actually managing the configuration piece of it is a little less daunting as well with the SQSQ method. Thank you, Ahmed.
You're welcome. No problem.
Okay, thank you.
All right. Well, we're a little over, but happy to have taken your questions. Thank you all for joining, and we'll see you on the next one.